Hi everyone, I hope you're enjoying Soapbox Science so far. My name's Inga, I'm a doctor and a PhD student at University College London. In my research I study a rare type of cancer called chordoma, which is spelt this way. You'd be forgiven for never having heard of chordoma, in fact a lot of doctors might not have heard of chordoma, given its rarity. When I say that it's rare, I mean that around 50 to 60 people are diagnosed with a chordoma in the UK each year. To put this into context, around 50 people are struck by lightning in the UK each year, so it's pretty rare. If you're unlucky enough to be diagnosed with a chordoma, for the most part you'll be in your 40s or your 50s, so well into adult life and probably in the middle of your lifespan or thereabouts. Chordoma is a tumour that grows in bone, and it affects the bones in the middle of the body, or it grows in the bones in the middle of the body. That is to say, it's unusual to find chordoma in the bones of the arms or the legs. It's generally in the bones at the bottom of your skull, where it joins with the spine, in the bones of the spine, also known as the vertebrae, or in the bones at the base of the spine, the tailbone, otherwise known as the sacrum. What's peculiar about chordoma is that if you take a sample of the tumour and you have a look at it under the microscope, as a lot of doctors do, what you see is something that doesn't look like the bones of an adult, but more like cells that you would find in the developing baby, the unborn baby in the womb, also known as the embryo. Specifically, what you see looks a lot like the sort of early temporary spine that we see in the baby that is later replaced by the bones of the final spine. Essentially, it looks like something called the notochord. So, as I said, the notochord is a sort of temporary placeholder before the final spine develops. It's still there to provide structure to the developing embryo, but eventually it will be replaced by the bones of the spine, such that by the time a baby is born, the notochord, the cells of the notochord, have completely disappeared and are replaced by the bones of the spine. This is a bit of an unfamiliar concept, but it's a little bit like having baby teeth at the beginning of your life that are then replaced by your adult teeth. The baby teeth are just there temporarily, and then your adult teeth will then last you your life. So one of the questions that puzzles me as a researcher is why we see this tissue that we would normally see in an embryo, but in an adult, and not just an adult, but an adult in their 40s or their 50s, so well into adulthood. To understand this, let's take a step back and think about how you develop a human being in the womb. Once the sperm has fertilized the egg, you start off with a small ball of cells, really just a few cells. And if you think about it, from those few cells, you'll have to make all of the organs and parts that make up a baby, never mind an adult. All of the specialised tissues, such as the heart for pumping blood around, your brain for thinking, and so forth. So these early cells in this little ball of cells are called stem cells. This means that firstly, they're unspecialised, they don't have a specialised function. And secondly, they're able to divide into lots of different types of cells, for example, and that they're able to divide quite a lot. As these unspecialised cells divide, we say that they begin to differentiate. And what this means is that they become increasingly specialised with various cell divisions. And specialised cells are great because, of course, they're perfectly suited to carrying out their special function. For example, the muscle cells for contracting, the red blood cells for carrying oxygen around in your blood. But as they become specialised, they give up the ability to become different types of cells. So once you become a muscle cell, for example, you're not going to become a red blood cell, and once you're a red blood cell, you're not going to become a muscle cell. In fact, as a specialised cell, there are generally pretty strict controls on how you divide, for example, when you need to replace an old cell. And the reason for this is that it maintains the harmony of the body. Each specialised cell has its rightful place and function to maintain the harmony and the community of the body. So, to come back to the notochord and chordoma, the notochord is one of these types of unspecialised cells. It's essentially going to eventually specialise and be replaced by the bones of the spine. And what we think happens in chordoma is that in a subset of people, these cells never make it to their final specialised state. They get stuck somewhere along that journey from becoming an unspecialised cell to a specialised cell. And we think that this is the first step towards becoming the cancer that is chordoma. So we've covered a few concepts in what I've spoken about today. So just to summarise, chordoma is a really rare tumour. A lot of people won't have heard of it. It's a peculiar tumour in the sense that it looks a lot more like something you would find in the developing baby, the unborn baby in the womb, the embryo. And the reason we think that this looks like this is because it's gotten stuck, frozen in time, somewhere along its journey from becoming an unspecialised cell into its final specialised tissue. And if I may, I'd like to leave you with a question, and I hope you'll tweet or respond to us some other way. So can you think of a time, other than when the embryo is developing in the womb, of another time in the human lifespan when cells have to grow a lot and divide a lot in a short space of time? And I hope you'll get back to us with your responses. Thank you so much for listening. I hope you enjoyed the other talks.